Reading and writing is so fundamental to life that it's really hard to imagine not being able to read. But 5,000 years ago, nobody had any idea what writing was, much less being able to read a bulletin board or reading road signs. And of course, we use reading and writing for learning. I'm here at Tufts University in Medford, Massachusetts to talk to Dr. Marianne Wolf about reading and learning and about how we're able to do it at all. So you study reading, and reading's a new thing. It's, what, 5,000 years old?
Absolutely. It is a blink in the evolutionary clock.
And it's something that we don't have the circuitry to do, right? It's just something that we figured out not that long ago.
One of the most amazing things when I started studying this was the realization that our human brain was never born to read. We don't have a single structure. We don't have a single gene. Rather, reading is something that our brain, it reflects our brain's capacity to do something new.
So can you tell me how that happened historically, and then how that happens maybe when you're a kid?
Yes, this is a fundamental insight. If the brain was never born to read, that means it has to form this whole circuit anew with every child that's ever born on the earth. What's so interesting about the reading brain is that it's an absolute example of how much we use our brain, not how little. When we first decode, the eye sends all its information to the visual areas of both hemispheres.
So this is the back here,
Yeah,
right?
the back here. And these visual areas go quickly across, get connected here, and then the real fun and work begins. You are connecting areas here that have to do with the sounds of the words. All the meanings of the word are activated at the same time. They're all getting hooked up here. And also all this area here in the frontal lobe is connecting some of the tiniest sounds called phonemes to the rest. So within 300 milliseconds, all of this brain is being used. Somewhere around 3,500, 3,000 BC, we had the beginnings of symbol systems from the Sumerians and Egyptians, and those became ever more abstract. There were a few other writing systems that we could talk about, but I just want to say that there were about 2,000 years between that kind of writing system and what we think of as an alphabet, a system in which a letter, a visual character, stands for the sounds and language. So it took us about 2,000 years to get there.
So when you talk about, obviously we all know hieroglyphics.
Yes.
We know what Chinese characters look like. Those are fundamentally pictures, and what we use are things that represent something else. What's the difference between drawing a picture and writing a word?
This is such an interesting thing, because if any of us would say, what would we do to set up a whole symbol system if we didn't have one? We would probably begin, just as the Egyptians began, with pictographic system, a system that had objects in nature with a symbol for them.
So if I wanted to represent tree to you, I'd draw
That's
a picture
right.
of a tree rather than figure out how to write it.
And there are those who are researchers who say there are good reasons why the brain does that. That the brain is actually using these areas that it uses to recognize objects in nature. And so that our first symbols, voila, are recycling areas that you and I would, before scripts, use to identify objects in nature.
So the way I recognize what a real tree looks like is just the same way I'd recognize a picture of a
You
tree,
are
so you might as well do it that way.
You're using the same areas of your brain.
Right back here?
Absolutely. Fusiform gyrus.
Does the fact that so much of the brain is involved in reading have anything to do with the fact that we just figured it out? It's not like we evolved a spot for it. It's the whole brain's working on it,
It's a
right?
really important point. Our knowledge of the reading brain is really at the beginning. Imaging has changed everything we know and thought. Not everything, but we're able to literally see millisecond by millisecond all that gets involved. But reading is very complex. We don't just decode. We decode words and sentences and paragraphs and treatises and essays. And we bring to that reading circuitry differences in what the material is and how we read it. The real question for us today is how we have learned to read being changed in dramatic ways when we are screen readers. And right here, this area here in attention, we know that that child is attending not just to the text when they're looking at a screen and they have bells and whistles all over. They're attending to an awful lot of things. Will this circuit because it's being distracted and pulled to the next piece of information, the next piece? Will it fail to activate, or let's say, will it short circuit the entirety of those deep reading processes? It's a huge question that our society really needs to take very seriously before we lurch into the next new ebook.
So reading's still relatively new, and our brains are still figuring it out, which I guess is a good thing considering that technology is changing the way we read and the way we think, and we'll just have to adapt.